1 second. Okay, so we talk about industrial or application case in many sectors. First of all, I try to mention that we will work on this example on a case. I show you a simple case that we'll see in detail maybe on next day. That is the use of intelligent agent computer-generated force for analyzing complex systems. This model is called Panopea, is not classified. It reproduced piracy operation in the Indian Ocean and Aden Gulf. Around 10 years ago, 15 years ago, this was exploding, maybe less than 15, whatever. And the problem with the pirate over there is they don't have a ship with the flag of pirates. They don't have Jolly Roger. They don't look like pirates. They look like a small, medium-sized boat of fishermen, but when the target arrives near, they attack. The area is very big. In this area, there are 1,500 small, medium-sized boats that could be suspected. There are around 100 commercial ships or more. They travel back and forward. So many targets, many potential threats. And the difficulty is to identify the threat in the traffic. What was the scope of this model? The scope of this model was to identify the best combination of vessel to patrol, what kind of vessel, what kind of equipment. It makes sense to put a drone on this vessel, yes or no? It makes sense to send a helicopter to patrol. We have to follow direction of intelligence, or we have even to patrol. We have to follow recommendation from Yemen Coast Guard, or we don't have to trust them. We have to, when we have to board a ship, a boat to be inspected, what should be the procedure? We have to escort our ships. For instance, Italian Navy have to escort his own ship that cross the area, or we share with other Navy to protect all the ship. There are many different decisions. Some are operational, some procedure, policy, some are technological, and so on. This was done for several purposes. By the way, it's very interesting. I was in this case, I mentioned a note. I was hiring a scientist, very good, that was a mathematical master, a girl with mathematical master, that was extending study in ethology. I don't know if anybody of you know what is ethology. Farinella, you're here. Thank you for visiting. Federico, okay. Anybody knows what is ethology? Rayane.
Professor, you mean methodology?
No, ethology.
Okay.
Do you know?
No, Professor.
No problem, no problem. Fabri, Stefano, do you know? I don't hear you.
About moral, Professor?
Sorry, I don't get the message. Could you repeat?
It's about a moral?
Bad moral?
Yes.
I don't understand the word. So can you write in the chat? I beg your pardon.
Yes, yes.
Professor, I guess it is related to the reason, yeah? The reason of something, historical something.
No, not really.
Okay.
Professor, if I don't make a mistake, it's a science about objective behaviors, if I don't make a mistake.
Exactly. You're right. You and Ahmed, you're right. Ethology is the behavior, but is the behavior of animals. Okay.
That's right.
In the artificial intelligence, in this case, I was not in synchrony with a large part of community. They say that we don't have to use ethology to study human behavior, because behavior of humans is different from that one of animals. But in this case, vice versa, we was quite successful. There are animals that have very interesting behavior that makes sense to study. For instance, wolves. Wolves are among the few animals they do ambush. Okay. During Middle Age, wolves are supposed, based on literature, to literally attack town. There are reports of attack on large town like Florence by wolves in packs. Okay, and in fact, if you remember, during the Second World War, the U-boat from Nazi was using wolf pack attack to the convoy of the Alliance. In any case, in this case, why we use ethology? Because, you know, Ahmed, for instance. Ahmed, do you know that, so thank you even very much for your comment, by the way, Azal. Okay.
Thank you so much.
When Ahmed, when you, I don't know if you never, do you never go fishing on the boat, Ahmed? I don't know where you live, so I don't know.
Yes, I'm here.
Do you never sail a boat to go out for fishing at sea?
Yes, a few times.
Okay, so when you go out for fishing, if you see a patrol vessel of the Coast Guard that approach, that make inspection, are you happy or not?
Yes, Professor.
Okay.
I sometimes go for fishing at the rivers around.
Okay. In Italy, normally we are not very happy, okay? Because they stop you, they make control, eventually they raise a ticket. In any case, you lose the time to talk with
Yeah.
them, to show document, etc. If you are a professional fisherman, you don't like too much because you have your net at sea. If they stop you, you lose fishing time, you lose production, you lose time and money, basically. So if I'm a fisherman boat and I see this vessel that approach to inspect, I will not escape, obviously. But I will try, let me say, to move smoothly, a little bit out, slowly, slowly, slowly. But at the same time, if I'm a boat with pirate on board, if I see this vessel, I not escape too, because I suspected to escape, you know. But I will try to move inside the other fishing boat in order to be in a mix of a larger group of fishing boat where they cannot find me. So this is kind of behavior like a swarm, no? Swarm of fish that go around. Do you know that there are swarm of fish, small fish that swim all together in order to confuse predators, no? So we was creating model like this one to reproduce not comparative behavior, both of good guys that don't want to lose the time in fishing and bad guys that want to do the pirate but try to look like a fisherman boat. That was very interesting. And we investigate many other aspects, such as in cooperation and collaborative model among different entities. For instance, at that time, Russian Navy was operating there, like some Chinese ship, some Japanese ship, the NATO, etc. And one question could be, it makes sense that NATO and Russian cooperate over there? For instance, let's assume we have two areas to patrol in two square, two adjacent cell, one each to the other. If the boat that I would like to inspect is almost on the edge and is going out of my zone, it makes sense that I try to intercept it far away, traveling for a lot and missing possibility to inspect other ship. Or maybe I can call the Russian ship on the other square and say, look, this boat I know is suspected, please inspect. This could be cooperation, could be good, I don't know, depending if each of us trust the other one. Another even easier aspect could be, okay, I inspect this boat. This boat is going on the next area to the Russian. Why I don't call the Russian and say, I already inspected this boat. Let it go because I check it, it's fine, okay? So as you can see, synergy could be positive, but I could be even negative because let's assume that I'm patrolling one area and they call me from a coast guard of a country on the side. Say, look, we see suspect pirate activity in on east of your zone. So I go on the east and then there is attack on the west. And after a while, somebody tell me, okay, there is a suspect activity on the west another day. I go on the west and they attack on the east. Maybe that is Coast Guard have some kind of corruption, and they give me deliberately wrong information, okay? So the best solution, maybe don't trust them. This is very dynamic situation and is interesting to study. Another example, the best way to get pirate is not to patrol. The best way to get pirate, because the sea is huge. We have few vessels over there because the cost of a military vessel is very high. So what is a good solution is to get intelligence. Maybe some person that is on the coast that is provide us information secretly, tell us, look, this boat was sailing out of the port or of the beach. I see many one with machine gun, with assault rifle boarding this boat. This boat is called this name, is moving this direction. And so I go there, but I already know that it is not easy to find, because when it's between the other one, maybe I get confused. No? But intelligence normally is not provided to the ship, because intelligence is confidential information. Often doesn't go even to the local authority, but to the local command, but it happened that it's sent back to the capital. So for instance, there is an agent that is working for Italian intelligence, will send this information to Italian intelligence, they will send the information in Rome. In Rome, the Italian intelligence will process the information, will check, and then will transmit to the ship. But you know, this takes time. So maybe the ship get the information when the attack already happened, or when it's too far away to act. So one idea could be why we don't transmit the information to the ship, and we are more reactive. That's a good idea. But on the ship, you will check the information, because in Rome you have a team of experts, you have tools, you have data, you cross the information of this agent with information on the one, etc. And I give it to the ship just very reliable information. On the ship, I don't have anybody that is does this work. So it means I needed to take some person of the crew and train to do that. I need to provide them some tool. I need maybe to bring on board somebody more, and it all around 24 hours, because the ship will sail 24 hours a day, and a military vessel sail always as in war condition, working 24 hours a day, 7 days a week. In addition, I will tell you, if I get this information on the ship, I will have the same capability than the command in Rome, that, by the way, the command in Rome don't close the loop, because command in Rome probably will communicate with the command of NATO force in the area that will make another check and will communicate to the vessel. If I go directly to the vessel, how many false alarms they will not able to discriminate? How many times you will have to move to check things that don't need to be checked? So there are positive and negative. This was devoted to that. It is a good example. I make you another example that is about Haiti. In Haiti, there was a huge earthquake. I don't know if you remember. It was 2010, I feel. And it was mostly flooding the town of Port-au-Prince, a town with over 2 million inhabitants. We was working in synergy with the U.S. Joint Force Command, that was the joint command of U.S. force, including Marines, U.S. Navy, U.S. Air Force, and U.S. Army, and with the South Command of United States to create a simulation about this operation. It's a public domain information. I just give you public domain information. We was working with the other one. Someone was taking care of logistics. Someone was taking care of operation. We was creating a simulation where he was able to fly a plane over Port-au-Prince, seeing the damage, or drive a Hummer, you know, such big Jeep around, seeing the people yelling and the problems. And we was in care of simulating the population of Port-au-Prince, as well as the food distribution. And to simulate the human behavior in terms of stress, fatigue, aggressiveness, fear, because humans, where you distribute food, react to this action. Now, I cannot predict if at the food distribution point there will be a riot, but I can make analysis by this model to understand if there is a risk of riot, if it's more safe to send the local police to distribute food, or it's more safe to give it to an NGO organization, non-government organization, if it's more safe to send the troop to supervise, to send some soldier to keep situation quiet or not. Because, you know, if I put soldier, I will create a deterrence. So people will be scared to make protest. But when I remove the soldier, they accumulate stress. It will be even more aggressive. So I should have, if I don't bring enough food to see something less human, but more based on logistics, if I say I distribute food, but I don't distribute for the people that will come, then it's a high probability that we start a riot, or that as soon as I leave with my force, that we start a riot. And this is an easy situation, because if I'm in the United Nations, I distribute food in an area where there is war in some place of Africa, to make an example. I go down and I distribute food, okay? Very good. Distribute food to local population. Then I leave, because I have to distribute food to 300,000 people that are in bad situation, okay, for food, because there is war and there is scarcity. So I leave to go in another place, to bring food another place. And the area is huge even for my vehicle and my vehicle. But as soon as I leave and population have taken the food, here arrive a local warlord with his local force that is a significant military force. These people start to kill the people to take the food, and then sell the food or use the food to impose their power on the area. So it makes sense that I don't distribute the food, but people will die. Or what I can do, I can call the Lord of War and say, look, I know that you use food in this way. I give to you the food, but I give you much more food. So some food should be given freely to the poor people to don't die. And this could work. But look, the people of the area, they will think that I'm corrupted with the local Lord of War. So we don't trust me, we not trust our policy. So what is the right solution? The point in this environment is there is no right solution. There are many alternatives. We have to investigate the best one. This two case was, let me say, military oriented. But you see, it's not traditional force to force. I was talking about a humanitarian operation. I was talking you about another United Nations mission, because anti-piracy was directed by United Nations, and how to coordinate with the other one. I'll give you another example. We will see this one, and maybe you will experience even. This is a case where we had UxV. We call UxV means unmanned any domain vehicle. So it means autonomous robotic system that could be flying, that could be ground vehicle, that could be, now this is land operation, so no sail, not surface sailing on the sea or underwater. In this case, the goal was to prepare people to operate UAV, small UAV, inside and outside building in plants in case of contamination, and to have even small vehicles like this one that can go inside and collect people that has been contaminating and bringing out of the contaminated area. And the flying vehicle have even sensor to check if you are on the ground, what is your status. If in triage you are red, yellow, black code, unfortunately, or green one. So if you are green one, you can take care of yourself, and by a microphone, and a speaker, I can communicate, tell you what to do. If you are yellow, I can give you direction and maybe consider you a low priority. If you are red, I will try to send you some support immediately. If you are black, unfortunately, it's too late, and then don't take care. But I can teach people not only to support people that has been injured, but even to collect a sample, how to delimitate the range. But you can see it's completely new way. This concept, something very important, is the difference between the AI in the loop, or the man in the loop, and the man on the loop. These are two different criteria. What I mean, I don't know if you are aware how it works in UAV. I feel you see my screen, correct? You see my screen?
Yes, Professor, we do.
Very good. Now maybe. Okay. This is a Predator. A Predator is pretty big vehicle. This is used for weapon of damnation and destruction. In any case, despite this very military oriented, I don't know if this kind of vehicle, no, is a classic UAV. As you can see, it's bigger respected man. It's like an executive plane. They cost between 10 to 20, between 5 to 20 million this size, despite if they are very, let's say, bigger and powerful or small. But let me show you Predator. Ecco, control room. So the Predator that flies, the plane that we have seen before, you see it? This is how you pilot, okay? There are two operators. As you can see, this operator is, one is the sensor operator, and the other one is the pilot, okay? Often the command of these operations is carried out far away. For instance, there are one of the major control is in Tampa, in Florida. They control maybe operation in Afghanistan. No, to this you fly from this way. You can direct the plane like a remote controlled plane. No, all the communication are supposed to be proof against to be compromised by cyber attack or be jammed. Any case, it happened that some of that was taken under control by opposite force. Now, there is an interesting aspect. And you are engineer, maybe you can understand, okay? Let me stop one moment over here. You have operators. Let me see what I can ask. Amin Rosa Nizar Mary, are you here?
Yes, Professor.
Do you know how much time it takes to the light to travel from Florida to Afghanistan? Can you guess around?
I think more than 12 hours.
But no, light. What is the speed of light?
I think I said how much in pi? Yes, the
No. What is the time to send a communication? Anyone knows what is the speed of light?
300 million kilometers per second.
300,000 kilometers per second, okay? 300 million meter per second, 300,000 kilometers per second. I feel, maybe I'm wrong, but that's my memory. So if it's, you know, the distance between
3 into 10 power 8 meters per second.
Sorry? Could you repeat?
The speed of light is 3 into 10 power 8 meters per second, Professor.
Okay. 300, but it's correct, no? 300,000 kilometers per second, correct? Now you give me some doubt, but I feel I'm right. Someone can confirm.
It's correct.
Otherwise,
it's correct.
Yes, Professor is right.
Exactly.
It's correct, sir.
Perfect. So it's 300, okay, for more precise, it's 299.79, etc., but it's 300,000 kilometers per second, almost, okay? So the distance between Florida and Afghanistan, $7,000 miles around, okay? 7,700 miles. In kilometer, 12,000 kilometers. So how much it takes? Lady, I would like to get an answer.
It is less than 300 Sorry, a little more than the 300th per second. Sorry.
No, not 300. 0.03. Okay,
Yeah,
could be
0.0 300th. I mean 3
Vabbè,
over.
okay, it's good. Okay. So Oriol, but I need to see and then send a command back. So it's two-way. So it takes 0.066, correct? Eventually. Good. So it's a little bit less than 1/10 of a second, correct? Now let's see that I need to communicate through the satellite. Satellite will introduce some delay, no? Because I needed to code the message, decode the message, transmit to a satellite, transmit to another satellite, align the signal, retransmit, etc. So let's assume it takes just 1/10 of a second, okay? Is acceptable, no? As estimation. First rote estimation. Giusto, Anna? Può aver senso, correct?
Yeah.
1/10 of a second. It is plain, I don't know, but let me see. It's plain deeper, UAV, speed, 482 km, or Predator. Predator is smaller, okay? Predator, 217 km per hour. Can you convert in meter per second in knots, Anna? You know how much is a knot?
No. How much is what?
A knot, a nautical nodo, un nodo
No,
nodo.
I don't.
Okay, then sometimes we are used to use metric system, obviously, but as engineer, we need to be able to use everything, okay? So just to keep in your mind, we use meter per second, obviously. But often we use kilometer per hour when we talk, we drive a car, no, Anna? You don't say to your mother, I never exceed 40 meters per second when I drive.
No, we use kilometers per hour.
Okay, so knots have a meaning that was used originally in the ship, in the Navy, but are used even by plane. And is a measure that corresponds to 1 knots is 1 prime degree of the Earth circumference, okay? So it means that if you take the equator and you divide by 360 degrees, and each degree is divided by 60, this is the length of 1 mile. Nautical mile correspond to 1.852 kilometer, okay? 1,852 meter are equivalent to a nautical mile, more or less. And 1 knots is a nautical mile per hour. So respect the kilometer is not standard, but is used, as I said, in Navy and aviation, but is very physical because correspond to Earth characteristic, to our planet characteristic. Now, if you divide by 2 and increase 10%, you pass with the approximation. Otherwise, you do the exact computation. And if you need to do in the model, you need to do precisely. But just now, it's very easy to pass by kilometer per hour to nautical, to knots, because you divide by 2 and increase 10% or multiply by 2 and remove 10%. So we say 217 is 109 minus 10% is around 98 knots, okay? Now, the advantage of knots is that it's almost exactly to divide by 2 to get the meter per second. So if 98, let's say 90, even just say 90, or even 98. If it's 98 knots, it means is 49 meter by second, okay, with some approximation. 49 meter by second. So if you have a delay 1/10 of a second, you will see something that when you give the command back to the plane will happen after the plane has flight for 5 meters, okay, Anna?
Okay.
So it means that if I'm landing, when I see there we are near to approach, we are, let's say, 1 meter to touch, probably we already touched, let's say, some fraction of second before. And when I give the command to correct my flaps and my asset in order to properly land, probably already crash. Okay, Anna?
Yes, got it.
If I shoot a car, I will shoot 5 meters behind him. Plus the fact that my ammunition goes slowly, etc. By the way, this kind of predator don't have a machine gun usually on board. Okay. Sometimes they have, by the way. Sometimes they have. Any case, what means that these are unmanned area vehicles, but are not just remotely piloted. Why? Because when you operate in this way, there is some artificial intelligence on board that you give order to land, but in reality, there is some self-landing system. For instance, you say to shoot, but you don't shoot directly, okay? You say shoot on a target, and then track the target that you identify by itself and shoot at the right moment by itself, okay? So this is a mix of artificial intelligence and humans. But to operate one predator, like that one we say, that 99% don't shoot anybody, even if he shoots sometime, but 99% he do reconnaissance. So use camera, he stay on the air normally for 24 hours over an area. When he retire, arrive another predator. They have camera, they stay at 10,000 meters, so you don't see them, as you don't see something that is big like this one at 10,000 meters of distance over the cloud, and looks through spatial camera that cost probably hundred and hundred of thousands of dollars or million of dollars to look down, okay? But is, as I said, is piloted at high level. In this case, we can say that I have a man in the loop. That man in the loop is when the man control the system. In this case, it's controlled, but there is some artificial intelligence in the middle. Okay, so currently is still a man in the loop with some AI that interact or operate as a, let me say, trade union between the man and the device that is far away. Now we are talking about predator in Afghanistan from Florida, but what happens if we have a space mission on the moon? Is even much harder, no? Because the delay is bigger. What happens if we have a mission on Mars or on asteroid? Okay, so these are major problems for the future of you. But there is another aspect. If I need, for a predator, I need 2 men for each predator. One that operate the sensor and one that operate the plane. So I need 2 men in the loop. But can you understand that it's a lot of people, even if it's much cheaper than put the people on the plane? It's cheaper because the plane is smaller, because you don't need to carry a pilot. It's safer. If it should shut down, we don't lose the pilot that probably cost, let's say, almost as the plane in terms of training time that I need. That is a limited resource, etc. Sometimes these are not pilots, are just operator. Depends. Sometimes are pilots, sometimes are the operator just trained to fly one of these devices. But in reality, to put 2 for each one is a limitation. If I want to fly 100 of this vehicle, let's assume I create smaller plane, the Predator. Predator, let's say, cost $8 million each. Just I invent, but it's not far away. I want to create something that costs, for instance, a quadricopter, you know, a very nice professional quadricopter costs 4,000, 8,000. So it means 1,000 less. I want to create one that costs 80,000, that is smaller than a Predator, bigger than a quadricopter professional, but can do similar operation to a Predator. Okay, maybe not throwing missile, but I will have instead then 4 or 5 beautiful camera on a Predator. I will have 100 of cameras on 100 of vehicles that could fly low, fly high, and it's much harder to shut down, because shut down a Predator is hard, but to shut down 100 of these medium-sized UAV could be even harder because they are distributed. But I will need 200 people to fly this one. So I don't know if it's convenient. But what about if I put an artificial intelligence on each of that do everything, and the man is not more in the loop, is on the loop. What it means? He don't give commands. He don't give orders direct. He give task. So for instance, I say to this UAV, you don't have to flight more left, more right. I say, let's patrol this area. Let's adopt a spiral for patrolling. If you detect something, ask for support to the other UAV that are in standby. In this way, I can fly hundreds with few people and assign high-level order, exactly as we do today, for instance, when we have some kind of human reconnaissance, no? Whether it's somebody that coordinate the search and rescue at sea, for instance, and somebody that operate a different vehicle to search. Sometimes I call one and say, look, I expect it's at west. Let's go to west. Go to west. Let's look for that. They told me there is some kind of wreck of a ship. Let's see if you see it on the coast. So in the future, maybe I will do this kind of things. Obviously, to design this new system, to identify what requirement they need, to identify what are the more efficient algorithms, we need to simulate. We need our model. We need to use. And who arrive early will have a big advantage, okay? Since that this is an example for applying, not for military, but for industrial. For instance, I want to create UAV that fly around a plant to make inspection. So somebody say, you know, near to this evaporation tower, I heard a strange noise, but this area I don't want to send a person because if there is a problem, maybe there is some spill of toxic waste. Maybe it's not an evaporation tower. Maybe it's a chimney or the part of a chemical plant where there are some kind of safety nozzle that could be activated in case of high pressure. That could be dangerous if somebody is then surrounded. So I sent this drone. But this drone maybe is not to be fly directly by an operator because it will be very hard to have good operator in each plant. But it's fly by an artificial intelligence. It get many input from the machine, by the sensor, by the people. It combine, it decide what to do. It goes over there, carried out operation and reports back. So can you imagine the potential of this one to increase safety, to reduce pollution, because I can go to measure pollution in very different places to realize if everything is going as expected. So there are huge potential for using this technology. Okay. And an important concept is that one of MS2G, that is modeling interoperable simulation serious game. We'll see what it means. That could be operating to improve performance in good time and to manage crisis during hard time. And we need obviously this model, and we need a person that are able to develop this model like you. I'll give you another quick example.
Sorry, Professor.
Yes.
Do we consider autopilot as the artificial intelligence or not?
You should apply Turing test to do that, okay? I mean, no, you ask, you put on the other time of the screen, you pose question and you see. No, this is a joke. I don't know. It depends what kind of autopilot it is, okay? Last Friday, there was not a guy of RINA, but RINA developed a system that correct the course of the ship. He was not there. Maybe it will be on the 6th of October. That collect data on the ship and consumption of the engine of the ship, and correct the asset of the ship and the course to reduce consumption. Okay, I don't know if any of you never sail a sail yacht, but when you are at the rudder, when you are the skipper of a sail yacht in a race, in a regatta, you will look to the environmental condition, you look to your sail, to your riggings, to your mast, and you correct the regulation as well as the rudder second by fraction of second by second to take properly the wave, to improve the efficiency of the sail and to go faster. Okay, and maybe sometime you try something, no, you try to pull a little bit this rigging and see if it's improved. If it's not improved, maybe you release it and you try something else. So it's a trying and see what's happening. It's an interactive, as you do by car sometimes, no? So it's not only one way. You are in a closed loop. I feel it's an artificial intelligence if it's in closed loop with some smart capability to understand what is going, what will happen. Okay.
Yes,
But
actually,
it's very hard to define if something is intelligent or not.
yes, actually, I mean, for example, about the Boeing airplane, all of them previously, in the previous century even, have autopilot, and it is just going the way they define a destination, and the plane flies to do into that destination. But right now, when we say about the artificial intelligence, we actually anticipate that, for example, the drone make a decision arbitrarily, it by itself. Yes. It is not just going the the route that we define for that.
Let's say that arbitrary is not very. I will say currently arbitrary capability, artificial intelligence is pretty limited. Okay, there is a lot of discussion. Probably you heard about the self-driving car that should decide if you have to crash against a tree to save a child that is crossing your road, and maybe put in the question to decide that he crash on the tree and you will die on the car to save a lady and his child or more people instead of one single. We are far away from this one, okay? Currently, we address a problem that is called law, that is about lethal force use, because what happened when I shoot against people, no? You know that at war, we can shoot people, okay? There are regulations, there is a Geneva Convention that describe when you are authorized to use lethal force. And we are not legal, but for sure I can summarize that you are authorized when you have a big advantage, respect what you will achieve, and you don't affect some kind of people like civilian, etc., or you affect in a negligible way. I'm not introduced in that, but I mentioned just what I remind. But any case, some people say, now if I give order to a drone to shoot, for instance, to a truck or to a bridge, to shoot a bridge with a missile and to destroy the bridge, I give the target as the bridge, I push a button, then the drone throw the missile and guide the missile by itself against the bridge. But if there is a bus of kids, a school bus that is passing over, it should have the capability to abort the mission, no? Like a human pilot can decide to abort the mission or not. Who is responsible for this collateral damage? Who is responsible for this child that died? But even not for the child, even if it's just a man that is driving his car over the bridge. Is responsible the programmer of the artificial intelligence? Is responsible the designer of the architecture of the artificial intelligence? Is responsible who trained the artificial intelligence? Is responsible the pilot? Who is responsible the company that delivered this system to the defense? Who is the responsible? No? My answer is, up to now, the idea is that autonomous system, robotic system should not be allowed to use the lethal force without authorization by a human, okay? So there is a human at the trigger. But I will say you something that I feel could make you to reflect on the problem. Let's take a gun, okay? I take a gun in my hand and I point the gun against one person, okay? If this person is 50 meters from me, I shoot the gun. There is a bullet that is exploded out, take its trajectory, depending on many boundary factors like wind, characteristic of the air, my movement, because maybe I'm moving, the movement of my hand, the tremble of my hand, what is the movement of my target, and many what is the good my precision, my in firing, etc. I will hit or not hit this man. Okay. In the moment that I shoot the bullet is regulated by physical law, affected by many factors. Maybe I cannot write down an equation that regulates it because I don't have all the detailed boundary condition of the air or the environment of the wind, etc. that affect. But in some way, from my I shoot, is the physics that regulate if I eat or not eat, if I kill or if I just wound this man. When I'm controlling a drone and I do something similar, shooting a missile, is really different the drone from the gun? Because, okay, the drone corrected the trajectory of the missile, tracked the target, etc. But I was myself that I trigger, myself that decide to shoot. No? So you can, this is another extreme point of view, that artificial intelligence up to now is just something like a self-guiding system of a bullet, but is nothing dealing with the responsibility to decide to shoot. Okay. So I feel that we, as engineers, this is a major ethical issue. Hopefully 90% of the case, or 90% of the case, we don't deal with use of lethal force, but we deal with industrial application. Classical new interesting application of drone. By the way, drone made by Italian company. The first drone in use by United Nations was to patrol area in Africa, to protect a safe area, to give support to population, not to fire any missile. And for sure, there is a huge potential for using that probably make much more money than that one that we use to shoot few missiles in some area. But in any case, in general, what it means, that artificial intelligence can help humans. At the moment, is not more performing than humans. In the future, it could be performing almost as human. Please keep in mind the example of Deep Blue, the chess computer game that was beating the world champion, the human world champion, about 25 years ago, 23 years ago, after being defeated. 1 year was defeated, the year after that one, he was winning. But nowadays, we know that the best player game is not a man, is not artificial intelligence, but is a man that play with us his side an artificial intelligence engine that support him playing the game of chess. Okay, and I feel that for a while, this will be the right way. And for sure, for you, probably 90% of the application will be in this way. Our artificial intelligence support usually use that because still need of knowledge that is not yet digitalized. There is still creativity and inventive capabilities, imagination that machine up to now, they don't have, okay? So there's still an advantage. In the future, I don't know. But we will discover. As Shakespeare say in Julio Caesar, you just have to wait at the end of the day or the end of the next decades to know what will be the end. At the moment, we have to keep in mind this aspect and be sure to prepare systems that are safe by design, and have a potential to increase the performance and the quality of life of people, if possible. Okay. So I feel we can stop almost over here. I will like, what is Kasparov? Yes, Rayane, you are a good chess player, right? Rayane?
Yes, sir. Yes, sir.
So maybe sometime we'll play together.
It will be nice.
I'm not a great player of chess, but I'm very proud that among a dozen, no, let's say, yes, a dozen games with an Italian chess champion that was retired from that, was a champion 10 years ago, I was winning 1/3 of the game. So I'm not so bad, but I'm not a professional chess player. So probably you can beat me very easily. Any case, I feel that in the future we see artificial intelligence move far away from chess board. Okay, we see already all around us many applications, even very simple one that could give a strategic advantage. And today we talked a lot about weapons, operation of defense, but believe me, the majority of the opportunity are out of this field. This is interesting because it investigates some capability. It's interesting because it proposes some intriguing problems, but the real business is out of that. Who is making the business is Alibaba. Okay. It's not the Sukhoi that produce a fighter for Russia. Okay, so it's we have to keep in mind that, because we can do a lot of positive things. I'm not against defense, but often it's a smaller business. Think about that. The defense usually absorb between a little bit less than 1% to 4-5% in the country that we consider very militarized. Okay, in Italy, I feel we are 1.2, 1.3, I don't know, but we can ask to Google. The healthcare system in a country absorb usually 10% of the money. So if you work in the medical sector, you make much more money than if you work in defense. And when I was doing work for the sector of healthcare before to enter university, I remember that, I don't know how you call, una barella. Come si dice barella in inglese? Somebody knows how to say barella in inglese? A stretcher, a liter, okay? Barella, stretcher, barella ospedaliera. Hospital stretcher, an hospital stretcher. Let me show what is an hospital stretcher, so even if I don't know. Hospital stretcher. You understand what I mean? For surgery. This one, for instance, you see? It's very nice one. I don't know if this is for surgery. I feel, maybe this is for surgery, okay. In any case, this kind of stretcher, in 30 years ago, it was costing like a Corvette. You know the Corvette car? I show you the Corvette car. It was costing exactly like this car, okay? This car, I feel, is 400, how many horsepower? Somebody knows? HP. Let's see. Corvette. Compra Corvette. I don't want to, I want to know HP.
Professor,
650.
unfortunately, we cannot see the screen. I apologize.
Sorry. In any case, let me turn out this one. I come back in 1 second. You hear me? Do you hear me?
Yes, clearly.
Okay, so I was saying that 30 years ago, I was doing consultancy for the healthcare sector. And one of these kind of barrel, maybe even easier, okay, stretcher for hospital was costing like, I don't know where it is gone. Other of this one, but it shut down. Like this carrier. That is 600 over 600 horsepower, okay? So it means that make more sense to make more profit working for, because it's strange than a stretcher that is a few kilos of steel, even if it's surgery steel, etc. It costs like a car that can drive 300 kilometers per hour with 600 horsepower or the equivalent in kilowatt, okay? So it's evident that in the medical sector, there was huge profit, a huge margin, and even there is a huge demand, let me say, because people need the drugs, need the treatment, etc. And so for this reason, we talk a lot about military, about the unbelievable cost of military sector, but costs are everywhere. Sometimes the big business are out. I told you Alibaba make much more money probably that one that produce plane in terms of profit, because they sell to million and million of people many items instead than few one that cost 200 million each, and that could generate huge problem in terms of engineering, service, maintenance, and so on. So never estimate other kind of business. There are business that seem negligible. I remember one of my students, one of my PhD, was making analysis in Afghanistan, so in an area where there are military operations, about the business of mobile communication just with the smartphone that you use, and was several $billion per year. So it means if you just are there and you're able to enter in the market of communication, maybe it's more respect Italy, French, and UK. But if we're talking about $1 billion. So even in a country that you don't expect so many people have a mobile, in reality, a lot have a mobile because there is not good fixed network. But in reality, there are huge opportunity of business in many sectors. And if you can improve quality of life, you can improve competitiveness, you can enter new market, you can increase profit, you can introduce new technology, you can make more safe the life for people and better. So thank you very much. Any other question? Instead that the screen is not visible. Ta-ta.
Thank you, Professor.
Thank you so much.
Thank you, Professor.
Thank you, Professor.
Thank you so much.
Thank you, Professor, for everything.
Thank you, Professor.
Thank you so much. Let me say that we will see next week that I feel will be the 5th of October, correct?
Yeah, definitely.
On the 6th, keep in mind that on the 6th morning, I will talk with, on the 6th morning, we will have this event similar to the last Friday. They will be partially live and partially on the web. If you are in Genoa or you can travel to Genoa, please inform me because I need to know the number to guarantee the safe operation, considering the increasing risk of COVID-19 in Italy. And if you are remotely, you will be connected remotely. Maybe I am already. Any case, you will have opportunities to meet with industry, meet among yourself, meet with the second class, the 2019, and it's just a small step, but it's another step forward, okay?
Okay, Professor.
Okay.
Good job.
Thank you.
So have a great time.